It's not like close the doors.
Why don't you close the doors and then start? Okay, let's, as they say on the airplane, take your seats and put on your seatbelts because we're going to start soon. And the doors are closing. And put all your phones in airplane mode. So as Oli is walking back, welcome to Six Man, and welcome to Bangkok. I hope you're having a nice IETF. Here's the Noel, which I assume you all have memorized and can answer questions about. Our boilerplate that we are all supposed to know. And we now have, thank you, Barbara, for taking minutes. And who was
Michael Atkins.
And Michael is a Jabber scribe. Thank you. So we can actually have a meeting today. And you can find all the presentations online, and this is being covered in MeetEcho. We will have, I think, 2 remote presenters today. Here is the agenda. There are 2 working group documents that we will discuss. There's, in the order of 4 or 5, individual submit drafts that have had lots of discussion. And then there are 2 new drafts that we're giving 5 minutes to, and hopefully we will have enough. We'll try to manage the time so they can actually be presented, but we won't reach any conclusions on those. Any questions on the agenda? Okay. So did you want to? Yeah.
Okay, so to quickly go through the document status since the last meeting, we published 1 RFC. That was actually mine. RFC 8425, shortest we've done ever, I think. We have 1 document in the RFC editor queue. It's the node requirements document. So expect that to be out quite soon. We have 2 long-running working group last calls. It's a segment routing header document since end of March. That has a session following this slot. I'll expect that the next steps for that document, when we close all the issues in the tracker, will be to issue another working group last call, because that document has had lots of changes. And then there is the router advertisement v6 only flag, which also is on the agenda today. Been running since mid-September. We have 2 active working group documents, but as far as I'm aware, nothing has happened with these 2 since the last IETF, which was in Montreal. Yeah. And in other news, Bob and Steve Deering has managed to publish the original zip specification. Almost published, sorry. Yes, it is in the RFC editor queue, right? Yes. So now you can enjoy how the original proposal for IPv6 started with zip. Suresh.
Yeah, so it just went through the IESG conflict review, and it was approved like a couple of weeks ago, Bob. So yeah, and yeah, it's the publication. So people are saying like, why doesn't it have like IANA consideration section and security consideration and everything, and say, okay, this is a historic thing, how things looked like at the time. So yeah.
So this was how V6 was supposed to look like in Steve's mind. So it's good reading.
I can add, so there was a meeting where it and some other things were discussed, and there was the big debate was address size or fixed versus variable length. So the wisdom of the committee was to not go with variable, but to make what was then called simple IP double the address size to what we have now. So that's what we've been talking about since.
Okay, and six-man related work in other working groups. In IP Wave, there has been a document that we have reviewed, the 802.11 OCB document. As far as I know, and Suresh is, well, why don't you just say it, Suresh? I was in the working group too.
Okay, so Suresh Krishnan, so this draft has like been revised multiple times, but I personally don't think it has addressed all the issues that came up in six-man review. So I told the authors that, like, you know, they had to like just close the loop on all the reviews that came in six-man, and also close the loop in IP Wave about the changes they made regarding that. So once it finishes up in IP Wave, I'll bring it back to six-man so we can take a look at it. At least, like, I think there's some of Lorenzo's stuff and some of Brian's stuff that's left out from there. And Eric Nordmark sent a review straight into IP Wave as well, which has some six-man related issues. So I think, like, once all those are covered, I'll bring it back here.
And then there's been a question from the Spring chairs on two Spring drafts that affects the IP6 source routing header. It's the operations, administration, and maintenance in segment routing draft that's on the agenda today. And it's the service programming with segment routing drafts. And it's some discussion between the ADs and the chairs where those documents should belong. If anyone had any opinions, please come to the mic. So far, what we have said is that let's gate these on the base document, so we get that published first, and then we can make a decision on where they best belong.
So I'm going to talk about O&M
and
later.
Your name, please? Yes.
Zafar
Yeah.
Ali. I'm going to talk about O&M draft later, but there is no dependency on six-man, so we can discuss it more. So it can proceed in Spring Working Group. When I talk, I can explain all the details.
Yeah, but at least now you know if we can have this discussion on the mailing list as well. We will see. At least that's open at the moment. Then I think we haven't been very good at updating milestones. But these are the previous ones. We're done. So we invented some new ones. You know, should we do more documents to internet standard? We have this work going on now on path MTU. Do we want to, you know, we have segment routing already in the working group, the V6 only flag. And of course, the ultimate milestone is the universal deployment of IPv6. And I guess we can have that one there for a while. You know, our AD might nag us about fixing up our milestones at some point, but unless someone feels very strongly about it, this is just a FYI that we might have, you know, update them at some point. I see no one running at a mic. Thank you. Other six-man related stuff this week. MapRG has a little 5-minute lightning talk after this session on V6 security and privacy that someone's written a paper or two about. There's sort of a correlated MTU set of discussions in the TSVW group tomorrow on Wednesday, and a Spring as well on Wednesday, which might be of interest. Other things we've thought about a little bit, there is some discussion about using GitHub to improve, you know, document process, make it much clearer when you make document changes so that those are tracked and you do pull requests, so it's a lot easier to see text changes going in and more control of the whole process. Currently, this is just, you know, largely an experiment and something we could be interested in exploring, and certainly if individual authors want to use GitHub, that's an option. There's a separate BOF on that tomorrow called the Working Groups Using GitHub BOF, I think, yes, Wednesday. And we could also, not that our incoming rate is very high, but in V6 Ops, they're doing this, you know, review a document per week, just to encourage and focus the working group a bit. And that's something we could do as well if it turned out that we had lots of drafts to review. Okay, so that's this one. Any comments on that? And do we have Darren online?
We do.
Okay, Darren, the floor is yours. And just say, unless you can change the slides yourself, just say next.
Okay, I'll see if I get it.
Is the sound quality good for you guys, or is it a little?
It sounds perfect for me.
Okay,
How's it for you?
we can understand you.
Okay, if it remains poor, let me know, I'll kill the camera. Okay. So, good morning, afternoon, evening, everyone. We have a lot of participants online and looks like a good number in the room. My name is Darren Dukes, and I'm talking about segment routing header. Revision 16 of the draft is sitting, waiting to get authorized to get published. Hopefully that happens shortly. But we'll go over the changes between 14 and 16 and what progress has been made since IETF 102 and what our outstanding items are. And I'm going to get you to advance the slides, guys, because I don't see an advance button on my screen anywhere. So next slide. Great. Quick thank you to everyone who's contributing on the list. Most recently, there's been still a good level of discussion, so thanks to the folks who are doing that, and more discussion is welcome. So anyone with some thoughts, please go ahead and use the list to get those out. Next slide. For an agenda, we'll go through what's happened in the last call really quickly, the changes from 14 to 16, the open issues that we still have, and the next steps, as well as a bit of a timeline as to when we should be finishing up the open issues. Next. The last call update, quickly, we had 47 open issues. We've closed off 39 of them. I'll work with Bob and Ole this week and next to make sure the ones that are closed in 14 to 16 are correctly marked. I don't think they are yet, but we'll get that done pretty quickly. We have what I believe are 8 remaining issues open, and we'll talk about those today to some extent. We'll have time for questions at the end as well, so folks, what's the mic ask? Next. Next. Okay, at IETF 102, we had a number of next steps. We had tags that needed work. We had TLBs that needed work, management data plane section that needed, or data model section that needed work. Those are not done yet. The section that did get attention between IETF 102 and 103, which took most of our time, was rewriting the security section and separating the HMAC processing to the HMAC definition, and then showing why and how segment lists are secured within the deployment model examples that are provided. Okay, next. On the HMAC side, other than consolidating the text, revision 16 simply has additional verifications of checking that the current segment, the element at segment list, segment last, is equal to the destination address in the packet. This was something that was noted on the list. It was added in revision, incorrectly in revision 15 and correctly in revision 16. Next. On the deployment model side, we had action to talk about how the ingress filtering gets performed. And there's been a good bit of discussion on the list, both with the text that came out in 15 and then refining that a bit and fixing up and adding some additional examples in 16 to close these items. What we defined in revision 15 is a set of infrastructure ACLs with an example using a prefix to identify the set of SIDs that are accessed only internally, for which we want to deny external access to, and provide an example using a prefix to indicate which internal nodes had access to the SIDs within the SR domain, and provided example ACLs for those in order to define how the segment routing domain is secure from nodes outside of it using segments within the domain. And then we looked at permitting access to a set of SIDs that are requiring a HMAC validation to be performed in order to use them. And again, we used a prefix to aggregated that set of segments and identified how we would permit external access to those things from nodes, SR source nodes not directly connected to the SR domain. So we had some good discussion on that on list 2, and I think that's pretty much closed now with revision 16 of the document. Next slide. The security consideration section was rewritten. The primarily focuses on security considerations for the deployment models that are in the draft now. We looked at source routing attacks in 1595, identifying where they're applicable or not within the SR domain. So there's text that clearly specifies that now. We looked at service theft, topology disclosure for SR source nodes outside the SR domain in particular, and called out the fact that there's the ability to have either service theft or topology disclosure in some use cases, and in other use cases where that theft or disclosure may not be a concern. So, so the draft highlights where the risk areas are. In the ICMP generation, we just concentrate on the usual rate limiting of ICMP generation. And Ron last week called out an additional section that should be in there, for which we started some conversation on the list around mutability for the AHICB. So the entire SR header needs a mutability section in the security considerations. And once that text is kind of acknowledged on the list, we'll add it into the draft. I expect that to be pretty quick. Next slide. Next slide, we'll look at the closed issues. All right, so the 5 issues closed around edge filtering, issues 25, 26, and 68, ACLs and the HMACs where they concentrated on, but a couple of turned various issues, 62 and 63, that I consider closed. We'll sync up with Bob and Ole to make sure that those are in fact closed in the issue tracker now. The several Q&A questions that came up on the list from folks, Cheng and Ron and Joel. Thanks, guys, for bringing up those items. Those are wrapped up in revision 16. Next slide. So that leaves a set of open issues. Next. I have a set of issues with Adrian that we've gone over that I didn't update in revision 15 that I still owe the working group updates on. But we've got closure recorded in the document, at least separate document with Adrian on those. So I owe the group that one. Next slide. We have some tag issues, 3761, fully defined the tag processing. So that needs to come up next. Next slide. Along with TLV processing clarifications that are still open from the last IETF meeting. Next. Next. And so in the priority in which we're going to handle the remaining open issues, we'll be tackling the TLVs the next couple of weeks, getting the tag documentation shortly after that, and then concentrating on the data model. So hopefully by the end of December, I hope to have text out for these that wraps up at least the TLV and tags open items, and hopefully get into the data model stuff. So if we can just flip to the next ones. I think that's all I had, and we have at least 5 minutes, hopefully, for Q&A.
Yes, go ahead, Joel.
Yeah. And actually, if you want to flip to the next slide, we'll just leave it open.
Yep.
Well, Joel asked a question. Thanks.
Thank you, Joel Halpern from Ericsson. Thank you, Darren, for a lot of work and useful conversations on the changes in the document. I appreciate that. There was one question I raised towards the end of our conversation, which probably got lost in the email. No criticism of that, it happens.
Yeah.
But we've agreed on the need for using the encapsulation mode of SRv6 for a whole bunch of cases, and you've clarified that, and I really appreciate the clarifications. And the fundamental question I'm left with is, why don't we just use that all the time? because we get interesting corner cases if what we call node 8 and node 9, two different nodes in the SR domain, are sending to each other and are using an SR policy. They somehow have to know at the TCP level to use the SIDs as the addresses rather than the addresses, and they have to have support for both putting SIDs in the base packet, putting the SR header in the base packet, or putting an encapsulation. If we always used encapsulation, we'd remove complexity, we'd remove questions, and it would get simpler. And this, I'd like to know your opinion on the value, but then I think it's really for the working group to say, maybe we should just go with one instead of two.
Right. So as far as the first part of your statement where you said the TCP layer needs to know to use a SID or a destination address, when a host is communicating with another host in the example between 8 and 9 that we use, hosts are always talking with destination addresses. So if I'm going to joelhalpert.com, I use your destination address to get to you. Now the question is, how am I going to get to you? And that's where we use the SR policy, and the SID list gets applied into the SR header that particular node is adding to the packet that it is sending from node 8 to node 9.
Darren, if I can amplify, if
Yes,
A8 is sending to A9 and it gets a SID list, and as it has an SR policy and it wants to apply it, I get all that. If it uses the encapsulation mode, it works exactly the way you just said. The underlying packet is a packet from A8 to A9. There's an encapsulation with SIDs and everything works fine. But if you use what the draft says, which is that the SID list needs to go in the base packet, well, then A9 would have to go into the SRH, but A9 is not a SID. It can't go in the SRH. So in fact, there's no place to put.
No, the A9 can go in the SRH. It can go as the last segment in the SRH. It is a destination address of the packet.
So the SRH can actually have SIDs and non-SIDs. If we make things cleaner and always encapsulate, we don't get the special cases. Everything in the SID list should be SIDs. It really runs much cleaner. But so
yeah.
The question
Okay,
is,
so
there's some value in having two modes.
Mm-hmm. So I understand that. I think that if you look at the Linux implementation, for example, I'm talking to a destination. I have a segment list. I apply the segment list. It seems very straightforward. Now, whether I want to, it seems very straightforward when you look at the implementation. So maybe we need to continue that in a separate thread on the list and maybe get some more input on it from other folks. What do you think, Joel?
That's continuing this on the list is the appropriate thing to do. Yes. Thank you.
Any more comments? We have a few minutes for more questions. Ron, you must have a question on SRH, no?
Hey, Darren. Ron Bonica, Juniper Networks. I'd also like to thank Darren. There a lot of good work went into this since, 6 months. A lot of big changes.
Cool. Thanks a lot, Darren. I have no idea what time zone you're in right now and how you feel, but
It's okay. I had a nap today. I'm on the Bangkok time.
excellent. Thanks a lot, and we'll follow up on Joel's question on the mailing list. Okay, the next one is you, Bob.
So Ula, just like a question there, Suresh Krishnan. So like, would you do another last call on this soon, or like, I think it's just part of the last call resolution, or how is it going to work?
Oh, just as I said under the document status comment, that when we resolve all these issues, because of the large set of changes, we'll do a new working group last call.
Yeah, cool.
Yes.
Okay. So I'm going to talk about the RA IPv6 only flag. So the working group last call started on the 6th of September. There were many emails, decided not to count. There was also, as part of that, request for implementation, and we now have one implementation based on that. I want to thank to Lee Howard particularly for his detailed comments on the draft, many comments, and basically for everyone else's feedback. I think it's improving it. 3 new versions of the draft were published since the last IETF. with obviously the intent to resolve the issues, in the discussion on the last call. So I'm going to go through the changes, since the last IETF. Version 02, there we go. We added text to section 9 to clarify hosts not supporting this are not protected from V4 attacks. In the 03 draft, we reorganized the text about the problem state and applicability. We noted, added some text about the state of the flag bits in the RA, and this got extended in the next draft as well. I particularly noted that since we did the RFC that added more flag bits, there haven't been any RA bits assigned. Doesn't seem like they're getting used up quickly. Clarify text about logging configuration errors in section 6, editorial changes, and then a lot of changes in the draft that was just published on Monday when the repository opened up. We had a text about explaining better why this mechanism is based on RAs, and that's because all V6 nodes will receive RAs, so it will reach all dual stack hosts and hosts that are running V6. We added a mention that if you're using VLANs, the flag only applies to the VLAN that you're connected to, not all of them. We added text that administrators must only use this mechanism if they are certain that the link is IPv6 only. We made it stronger than previously was it should. We added ARP to section 4 that, for which protocols this flag applies to. It previously said IP, but it also really applies to ARP as well. We renamed the flag from 6 to S. The other flags are given alphanumeric labels, so I think that'll be less confusing. I sort of liked 6, but this is probably better. We added pointers in the document to the section of neighbor discovery, where it talks about which flags get validated. And then, so that also resulted in essentially we're adding that if you implement this, you should also check the state in RAs for consistency and then log that if there's a problem. We changed section 7 from should not to must not. We had an appendix on implementations and testing, and then many small clarifications based on the list discussion and editorial changes. I think the document is significantly improved. So we have one implementation. Bjorn did a FreeBSD implementation. It was, so many thanks to him. Was he remote today? In any case, it's probably the middle of the night. So it didn't take a lot of lines of code. He tested it with FreeBSD routers, FreeBSD hosts on Ethernet and Wi-Fi, and with Windows 10 and OS X clients. So, and then there was also a test of using a tool called Scrappy to sort of send RAs with the bit set and see what happens to legacy hosts. And so the results of this is that, I think in the FreeBSD implementation, we found that, this is implementable. It's not particularly hard or complex to do, and that setting the bit doesn't seem to break any existing code. So both good things to find out. So I have 2 slides. There are a number of issues raised on the list. So this is Brian and my sort of summary of that and what we think the answers are. First is, asserting that layer 2 filters are sufficient. And so layer 2 filters may not exist in all environments. This is to inform hosts that to not use V4. So there's incremental benefit even if you have layer 2 filters, but not every, like my home network at home does not have, I have no ability to filter at layer 2. It was asserted that, it's not needed because hosts can discover the lack of v4 service anyway. And I think it's hard to make this reliable, and the fact of using v4 to discover v4 services may cause other hosts to think there is v4. So I think this is a better mechanism. It's a signal from the administrator that the link is IPv6 only. Next one could be used by we could build a DHCP v4 mechanism, but of course, if there are no v4 services, then this is hard to do. This would require having v4 services. Then, it could be done by a management protocol or DHCP v6. And the use of management protocols is certainly used in a lot of, enterprise environments, but it's not used in all environments. It's not used on bring your own device environment, even in managed networks. We have lots of unmanaged links. And RA is the only universal mechanism that gets to all v6 nodes. Host behavior is suggested, not mandatory. So the words in the document is, this is a should. And, do this unless you have a good reason not to do it. The administrator is saying the link is IPv6 only. Obviously, should means that if you have a reason to do something else, you can still do that. But I think in the most cases, receiving the flag will cause the host to not use v4 anymore, and that's the intent. And the next one might cause interop issues among v4 hosts. We don't see this as an issue. The administrator has decided that this is going to be an IPv6 only link. So the fact that v4 will break is sort of a feature, not a problem. So the authors think this is ready to advance. Obviously, it depends on the working group. The implementation experience shows that it's feasible and it doesn't disrupt legacy IPv6 implementations. And so the question is, what are the next steps? And I think that's where Oli gets, come to the mic, and then Oli gets to talk.
Yes. Go ahead, Lorenzo.
Lorenzo Coliti, I don't have a problem with this, actually.
Good.
So, and unlike most people here, I do have some nits. So when the default router lifetime goes to 0, you enable IPv4. That seems weird. In the sense that it is normal for the router lifetime to go to 0 if the router loses upstream connectivity. And so now suddenly you've got all these hosts like, yay, turn on DHCP-v4. So maybe reword that somehow.
Yeah,
Think
if you
about
could
it.
suggest some text, that would be helpful.
Yeah, I don't know what to do, so I can't
Okay.
suggest text. But
But we'll raise that particular
I don't
issue
have
on
an
the
idea
list.
for you, but I just wanted to.
Right. I mean, that text got there based on list discussion.
Yep.
So we added that part. But
I can try to think of it. It also says, I'm going to replay a colleague's comment to me. Have you learned nothing from IPv4? And the reason I say this is, it says that this is the only version of IP on the link. Like, what about IPv10 or whatever it is? Like, let's say that no lower numbered versions of IP on this link are in use or something, right? Because you can bet your bottom dollar that like when we actually deprecate IPv6, I know we'll all be retired, but
Right.
that flag is going to be set to 1, and it won't be able to you won't be able to change it anymore because it's going to be baked into the implementation.
right. Well, when we get to do IP version whatever, we can
We can specify the behavior.
we can specify what the bit means to that.
But it's probably worth saying it now, right? And
Yeah.
finally,
It's
I
really
think,
hard to predict what happens in the future.
and finally, I think the nature of currently the nature of IPv6 provision is that if you follow the RFC, it's always slower than IPv4, and so you can avoid pretty much all of the attacks. It's like, oh my God, I've got a v4 only network and I'm going to send an RA and everything stops working. You can just say, look, if v4 configuration has already succeeded and has been validated to work, don't turn anything off, even if you get a flag set to 1. And I think that's really going to avoid pretty much all the attacks. And realistically, if you got an address and it's working, you probably don't want to don't want to stop using it, right? Like, what are you going to prefer, NAT64 over native IPv4? That seems silly. So, and I think that will really address a lot of the attacks.
Okay, so yeah, suggest some text, please.
Okay, Eric Vink. Just, I like the draft as well. There is one point in the introduction where you cite a lot of benefits of this flag. And the last one reads, on an IPv6 only link, IPv4 might be used for malicious purposes and bypass unnoticed, maybe unnoticed by IPv6 only monitoring, which is true, the sentence is true, but it's not a real benefit because it does not prevent somebody hostile still using IPv4 to attack IPv4.
Or some other protocol or.
Exactly.
Right.
So I would remove this sentence.
I would agree. I think there was discussion on the list about this as well.
Okay.
Yeah, so I think that's sort of overstating things. Any other comments?
Yes, Suresh.
Okay, so Rishkrishnan, AD hat off, like I like the draft, okay? AD hat on now. I don't want this to go down the same path as like MNO bits, because like the way things are shaping up, right? Like especially what Lorenzo said, right? Like kind of like set off my spidey sense a little bit, right? So if the host has started this v4 stack, it's the same thing, right? Oh, if the host has already started doing DHCP v6 and then the M bit is not set, then keep doing your thing, right? So like it all looks analogous to me. So are we trying to cram 3 values into 1 bit, right? That's always the question I had in my head, right? Like for MNO bits, like we are trying to do a little bit more. So I think one of the issues is like, we don't have a clear consensus on what hosts need to do with this flag. So that's kind of what I understood from the discussion, right? So people don't have an issue with this flag being sent as a hint or everything, but I don't think we have consensus like what a host needs to do. And I think that's the hard part, right? Like I saw an implementation, but once we try to standardize like what a host needs to do, then it's going to be difficult, right? But maybe the working group decides not to do it, but I think like we need to be a bit careful there. Like, if we hand wave that part, like it's probably not gonna work very well.
So not sure what the takeaway or what action I should take based on that.
Try to be a bit more clear on the host behavior, like what is expected, like, and I do see like shoulds in there, right? And maybe a little bit more description on like what happens, what doesn't happen, and if you try to take like Lorenzo's suggestion, right, like what you would write there, right? Like, so, oh, if you already started your v4 stack, continue to do it or not, like that part is not clear to me, right? Like how that would actually work. And we have seen similar issues like multiple times. We've seen this in DNA as well, right? In DNA, like a host router comes up, then another router comes up, and then you have to figure out like what set of prefixes you need to use. So I think this is like a common issue we've had in a lot of things, and we never solved this properly, right? And I just want to make sure that we try to take one more step on clarifying the behavior of the host.
I mean, we can, and I'm not sure I'm comfortable proposing it, but I mean, we could say you must do this if that, but I don't, I don't know that we can force, right? I think it's you figuring out the right word and what we expect and what we allow, I think is sort of hard, but I still find that, I think in cases where the administrator wants to run IPv6 only, this is a useful tool to tell the dual stack hosts to stop doing v4, but that, there could be devices that have a good
I'm
reason
like
to do
Lorenzo, I just
elsewhere.
don't know what text to put in there. I just have this uneasy feeling that like, it's not going to end well. Like that's why I'm not proposing any text or like changing it.
Yes, good.
Michael Abrams. So this is 6-man. I would want to define this flag, and I don't want to rat hole on exactly what the host does. And it'll be a lot. I think this is perfect. It's up to the implementer of the system to decide in each case and so on. We can have a document in 3 years with best common practice on how to handle this. People test it and they say, we have this use case or that printer, blah blah blah. Let people play with it. Let people find out what works and what doesn't. And then we write that document, because otherwise we'll sit here in 2 years and we will have nothing. So this is treat this as a signal from the administrator. Hey, don't think you should run V4 here. And then if people say, oh yeah, I'm going to put it as one thing into my four different signals that I'm using, that's fine. Write a document in 3 years.
So V6 Ops will get to work on this in a couple of years.
Well, yes, since we don't have V4 ops, I would say yes.
Right.
Okay, yeah. So, Suresh Krishnan, so if I understand you correctly, Mikhail, like you want the host behavior removed?
No.
Okay, so
Left as is. So there is a should, and exactly what is in that should and what it should, why it shouldn't do it and so on. Figure it out. 2 years, we can have a best common practice for a host implementers or something like that.
right, I understand you, and it kind of makes sense, but that's where the lack of consensus, like in this discussion, is happening. Is like people are rattling on like what should be done or shouldn't be done, right?
Yes. So let's not have that in this document.
Okay, your call, Ole. Like, where do you want to go? Because like, if there's no consensus what to put there, then that needs to go, right? So,
do you mind if I intercede? The M&O bits were controversial because people have been fighting for 15 years on what to do, right? And that fight is ongoing, and it's well and healthy, right? And so the reason the M&O bits are supposed to maybe tell you what you're supposed to do when people don't agree on what to do. And that's why the M&O bits are controversial, I think. Right. Just wanted to say that. And yeah, when people don't agree, they don't agree. It doesn't matter what you write.
right, and that's why 4861 took out the behavior for that, right? Like, because 2461 did have it, and we had to take it out because we couldn't agree.
Because it was too mandatory. It should have been a hint. So as an implementer, I'm fine with this actually, because what it does is like I can do something really dumb immediately, and then I can do something a little bit less dumb tomorrow. And over time, we can turn the crank on how much this actually disables things. Like what I'm going to do at the moment is basically like, okay, if it's been whatever, 10 seconds left on the clock, I've got V6 and a V4, maybe I'm going to set the DHP V4, retransmit interval to a half an hour instead of 2 minutes. I can save some battery like that. It's super conservative, but it's pretty much going to work all the time. I do it like, 20, 10 times in the first minute, and then 5 minutes, and then like instead of backing off at 2 minutes, I back off at half an hour. And then later on we can, I don't think, and the implementations are all so different from each other that I think that trying to write it down here is going to create more of a hornet's nest. And we're not going to have a one-size-fits-all solution. And I think a hint is fine. And specifically for the V4 thing, I think when you have a working V4 address, you should just say, for that I think is pretty clear. If DHCP V4 has already succeeded, this flag is void. And that seems clear to me. But
Right. I mean, because the thing that started this was when we did the V6 only thing several IETF meetings ago. And we saw that while there were no addresses assigned with DHCP V4, there was all the link local stuff happening. And that's sort of what we intended to stop. So I do agree that if you can get an address with DHCP V4, then this flag probably wasn't set correctly. Jen?
Jelinkova, I like this draft, and as a network operator, I just reread the host behavior section, and I think it's clear enough. So for me, as someone who runs the network, I think it's clear enough on what I expect from hosts, how I expect hosts to behave. I really do not think we need to go into too many details, but actually I like Lorenzo's comment about ignoring expired routers lifetime, because I do not think we need to forget about the flag. But yeah, I like what the draft is saying now. I think it's quite good.
So Suresh, don't go away, because I'm not sure from what I'm hearing here is representative of the mailing list discussion.
I don't think it is. And that's why I'm a bit concerned, right? Because I think we have fairly significant support for the text in the draft right now. And I'm not sure if it's going to hold on the mailing. Personally, I'm fine with what's in there. I just have this uneasy feeling, but I'm fine. That's going to go. But I think there's people on the mailing list who think otherwise, at least. So I'm personally fine with just progressing it. You just decide to send it off, and then we see how things go. But I want to see if there's anything that can be done to handle some of the criticism that came in, right?
I mean, my problem is that there is no obvious consensus on the mailing list.
Right. And the biggest concern I have is, right, like one of them came from like a big host implementer, and that's concerns me a little bit, right? And that's, I want to see if we can address it, but if it's not, it's not. It's rough consensus, right? So it's, but I will try if there's something we can be. I can probably like go, grab Dave and then talk to him about it, but that's something I would like to try to attempt to do.
That would be helpful.
What?
So, I mean, one thing I'll notice, it seemed like a lot of the email discussion was about the email discussion and not the words in the draft. And so maybe if we make an effort to sort of pull those back to sort of comment on text that's actually in the draft, it might be simpler, but we'll see.
Right, like Bob, like specifically, I was talking about the one that started it all, kind of thing, right? Like before all this happened, I was like, oh, I'm really opposed to it. That's what I was trying to like fake in the beginning of the presentation. But like, yeah, that is really the point I wanted to address.
So I'm now relaying someone called BZ.
I think that's Björn who
That's
implemented.
he did the FreeBSD implementation.
Okay, great. He said the 04 draft says may and no longer should restart v4 if the lifetime goes to 0. So it'll be host behavior on very weak. If v6 only worked, then why turn v4 on again unless you have the demand? I think the may is fine about this now. Okay.
Okay, thank you.
So we could do some consensus calls. I don't know. So one question I had was, do we want to do this or not? I mean, that's one question we could ask. And if the answer to that was yes, we could also do a consensus call here on should the flag be prescriptive, i.e. so the host behavior is testable and there is an actual way of seeing if the flag has an impact or not. Or if it should just be a hint and it's open for all what the behavior is and it's not going to be testable. Given what's going on the mailing list, I mean, we could try these calls in this meeting room and see if we get it verified on the mailing list.
Yeah, you would have to do that anyway.
Yes. Michael, did you have a comment?
So I talked to one of the host, large host implementers, and I told them I would like them to go up and say this themselves, but it was basically I got the feeling from them that they wanted the hint, and that was fine, and it would be part of heuristics. I think very similar to what Lorenzo said was the feedback from others as well.
Okay.
So I think if we try to prescribe in this 6-man draft that talks about the format of the thing, I don't think we're ever going to get anywhere.
It is quite prescriptive already, right? It says should stop v4 processing.
Yeah, but the should is you have a lot of leeway with that should.
Not a lot. No, not 2119
so
should is quite a strong statement.
Right. So right, but. Okay, so I would say if someone is going to use that should and say that the host is doing the wrong thing when it doesn't immediately hot plate turn off v4, I think they're going to lose. There is no way, we're not the protocol police anyway. That's not going to happen. So if the expectation is if we should in there and that most host stacks should behave hot plate, turn everything on immediately, we're delusional. That's not going to happen. That's my take from talking to people and seeing what's on the list.
But as an implementer, how would you know even what to do if it's all up to, well, I should.
Your life as an implementer is not knowing what to do. Like, you deal with it, right? That's what you do. You start with an empty editor. I was like, okay, what do I write today? And it's like, okay, well, the standard says this. Is that going to work? Yeah, kind of, probably not. Let's do something different. So for what it's worth, I think we're here to make sure that when you do something and you need to interpret with someone else, that's going to work as expected. And I think we're definitely overstating the level of requirement that a should poses. It says, the implications have to be carefully considered before doing something different.
Right.
And if you have a good reason, like, hey, I discovered an MDNS thing on this link that's v4 only, I better keep using v4, otherwise I can't talk to it, that's a valid reason. If it says like, or you could say, look, you know what, there might be an MDNS host on this link that only uses this v4 only. I'm going to try 3 times, and then basically like I'm going to like transmit more of IPv6 than IPv4, but I'm going to still try IPv4 every now and then because like I don't know. And I think that's all within the leeway of the should. It's perfectly legitimate.
And Michael, everything, and what Lorenzo said is that's my take on it. That's what's going to happen anyway, regardless of if we put a must or even if we got consensus from must, that's what would happen anyway. So we might just have a should, and everybody realize that yes, there will now be a time where people will be. It's like the whole happy eyeballs timer evolution. People started with, okay, I'm not going to give any protocol any headway. And then it's like, oh, this seems to work. I'm going to be a bit more aggressive in my next release, and then it's going to progress. That's what I think. And I think that's what the expectation should be. And I think this document is fine as it is.
Right. Okay. So, Michael, you didn't answer my question on what we should do to... should we ask questions? Is there any point in... How do we proceed with this draft? Because currently, as far as I see, it's stuck in non-consensus.
So I actually think that if we point out that this should gives a lot of leeway to host implementers, I do think we have consensus. Because, okay, there are some people who really want to prescribe this. They are never going to get that document through if they keep insisting that. So the question is, what do they want? It is better for it to have the flag over time, and it's a hint, or no flag at all. I would say that. I've seen a few people on the list that I simply interpret as the device must turn off IPv4 now, and not use it again as long as it sees this flag. But it could be a minority. Okay, I could be misinterpreting it as well, but I think we're never going to get consensus around that one.
Okay, and the text in the document now, again, uses should, which is prescriptive unless you have a good reason otherwise.
Right. And for me, that's fine. It gives enough leeway for implementers to do their thing. And then I say we write the best common practice document in a few years when we know more. I think that's the best path forward.
That works for me.
And so I think 6-man should define what goes on the wire and not try to specify host behavior when it comes to these situations. I mean, we're not talking interop here. We're talking about turning off a protocol, and this is an optimization. So we should not be prescriptive in this case, is my opinion.
Okay, one last comment. We are over time.
If we're really arguing about this, then I think if you water down the text so it's actually really a hint, then makes it easier to gain consensus, I think. Because host implementers are always going to claim leeway to do what they think they have to do to make things work. And if you water down the text, and if we really can't gain consensus on should stop all IPv4 operations, then we can say like, yeah, should really like tone them down, or should should attempt them less aggressively, or interpret this as a hint that IPv4, like definitely you can interpret it as a hint that off-link IPv4 is just never going to work unless the network's misconfigured. So I think, if we really, that could be a possible way forward. We need to address the security concerns for sure. And then if we do that and say, look, you can't just switch off IPv4 by sending one packet, because that's a big concern. And then we say, look, if we really can't get consensus on the current text, which implementers are going to ignore anyway, mostly, right, in the letter, then we can say just it's a hint.
But at some point, you're going to have little value in this flag because you're going to use lots of other indicators if there's v4 in this link or not. And why bother with the flag in the first place? Then if you water it down that much.
It's very useful to have positive, when you're writing implementation, it's very useful to have positive confirmation of intent as opposed to like, oh, this timed out, or there's an outage, or like something else is not working, or I have a bug, right? So I think if you get this positive signal from the network, you can take that under advisement. You don't have to do what it says, nor will we have consensus to say that. But you can say, okay, well,
it's a signal asserted by the administrator.
Yes.
Okay. Exactly that.
Last word, Michael.
Yeah, right. And also on the security section, I see a lot of people talking about, if and that and those. Basically, if you don't have first hop security or ether type filtering or RA guard and those kind of mechanisms, you're screwed at 50 ways either. We're making it 50 first. I mean, people seem to think that you can ever secure a fully open layer 2 LAN with a lot of hosts on it. You can't do it. You're screwed. You need to have that kind of security, otherwise it doesn't work. So yeah, I'm actually quite I don't know the word, but this keeps coming. This keeps coming up, and I'm pretty tired of it just not saying if you want security, you need to secure your lab. Period.
Okay.
Do you want to call the question?
So I actually wonder if I shouldn't sit down with Michael and Lorenzo and write a little paragraph summarizing what we talked about here and now and suggest I try that on the mailing list to see if it gets consensus, and then reflect update the document accordingly. Any views on that, Suresh? I saw you were raising your eyebrows.
Suresh, can you get Bob to do it with Lorenzo and Michael, so you can call consensus on it?
Yes, that would be better. Thank you. Okay, Jen, now you're up.
Hello. So we presented it in V6 Ops in Montreal because we submitted the draft after 6 months, so some people might have seen some of the slides already. So what it's about discovering NAT64 prefix, which is used in the network, and sending it to host in routing advertisement in array option. So why hosts might need to know NAT64 prefix? Because some of them might to do synthesis themselves instead of relying on DNS64, and validating stop resolvers, because every time you talk about NAT64 and DNS64, DNS people start crying and saying, no, it's break DNSSEC, validating resolvers could not do this. So if validating resolvers knows prefix, it could do synthesis itself. And there are IPv4 literals, and there are 464 XLAT use case. So in general, it's useful. Oli suggested that we already have 14 competing standards for this, but actually we don't. We only have 1.5.
At least 4, right?
Standard now. So why we suggesting 15, so third competing standard, is because array is universal mechanism to get network configuration to the host. You basically get one packet, you get everything you need quite fast. So there is no moment in time when your network configuration is actually incomplete. And also network is actually the only proper source of that information, because if I run the network, I know if I run NAT64, and if I do, I know which prefix is used and where that prefix is routed and so on. So we don't need to run any additional services, because one of the other ways to discover prefixes via PCP, and I do not think many people run the protocol. Also, it's secure because we just discussed, you're supposed to have array guards, otherwise you are in trouble anyway, and getting wrong prefix would be least of your problem. And also, we get out of this strange situation when you trust random DNS response to get a prefix to do DNSSEC later. Because if you're using 7050, which relies on host resolving IPv4 only name, getting V6 address, getting quad A record, and getting prefix from that record, it means that host needs to trust DNS. And if you want to do DNSSEC, I assume you do not trust DNS. So it's a kind of paradox here. So DNS people, as far as I know, really do not like way of discovering prefix via resolving names. So simple, we have a simple format. The key thing here, we only suggesting support only 96 prefix. And the motivation for this is to save size, because if you try to get a variable prefix length, it means that option will be now not 16, but 24 bytes. And unfortunately, arrays couldn't be fragmented, so it does make sense to save size of the array option. So type, length, lifetime needed because you might want to change the prefix from one to another, so you should be able to deprecate one prefix and get another prefix, and 96-bit for a prefix. So we have had some discussion on mailing list, And most of the discussion comes down to what to do with multiple prefixes. So how could you end up with multiple prefixes? First of all, this option, one option specifies one prefix only, but you can get more than one option in a single array. One of the obvious use cases is renumbering. I want to deprecate one prefix and get another, so you're sending array with one prefix with 0 lifetime and a non-zero lifetime for second prefix. But in general, it means that host might receive a array with multiple prefixes. So there are 3 actual scenarios when your host might end up with different prefixes. First, host managed to learn prefixes from their different mechanisms, 7050, PCP maybe even, and array. Second scenario is there is an array with multiple prefixes. And third scenario is multiple arrays coming from one or multiple interfaces. So it's basically multi-home host. So first 2 scenarios is actually no difference from what we have now. So what we're suggesting is if different mechanisms are used to learn the prefix, there is a recommended order. Because 7225, which is PCP, is a very sophisticated way to provide prefixes to host, and it's allow you to do a lot of complex stuff there. If host supports this, yeah, well, it could prefer that mechanism. And then array option is definitely should be preferred over DNS-based discovery because it's actually more secure and it's more reliable. If multiple prefixes with non-zero lifetime for some reason appears in the single array, well, for consistency, we currently saying it should do the same thing as 7050 says. The trick here, 7050 says you must use all of them. And as far as I know, no implementation actually does that. They all just pick up one and do this. But it's just for consistency because otherwise we'll get into complex behavior. But again, it should show implementations might not follow that. Third scenario, multi-homing. Okay, it's most tricky one because currently hosts are not dealing very well with different configuration information coming from different sources, right? So obviously, NAT64 prefix is specific to the interface it's received on, right? So if you have 2 interfaces and you get NAT64 prefix on one interface, you should not use it for traffic sent to another interface, which is actually, we're talking about MPVD here. So if host is not really MPVD aware, it could not really deal with that information. And it's actually true already for DNS. They're like, if you sit in, as I hope you do, on IPv6 only network here, and you try to run your VPN somewhere and you get DNS services via VPN, you might experience unexpected results, right? So really hosts should be PVD aware to deal with multiple prefixes as well as multiple DNS information. Okay, Lawrence and I had discussion about should it be called limitations or issues discussed on the list. I call it limitations because it's basically things which you cannot do with that option. Does not mean you actually should be doing it with that option. But so first, it's one prefix in one option for all destinations. You could not say, I want to use prefix A for this address space and another prefix for another part of address space. But to be honest, I still could not imagine use case when you really need to do this because you can, in most cases, you can do it with more specific routes in your network. You just route private address space to one translator and another prefix to another translator. And again, 7450, for example, also does not let you to get different prefixes for different destinations. So it's a kind of, the behavior is the same. We're not making things worse. Another concern raised on the mailing list was there is no way to signal to hosts that some prefixes should not be translated at all. But again, we're talking, the main use case for this is IPv6 only network. It's not situation when your network is actually dual stack, but you have NAT64 somewhere else and you want some traffic not to be translated. Also, because on v6 only network, even if you do not translate an address and have an A record, what can you do with it? Literally nothing. So if application really for some reason needs to have an A record, it could easily reverse the mapping because it does know NAT64. Also, by the way, private address space must not be translated using well-known prefix. So it's kind of a way, if you want to have your corporate network or something with private address space not to be translated, just use well-known prefix, because translator, at least as per RFC, must not translate using well-known. And again, it's the same problem which you would have with 7225 or 7050. Well, theoretically, you can actually do tricky stuff and specify different prefixes for different destinations, and as a result, exclude some prefixes from translation, but you probably wouldn't really do it in real life. Okay, and only support /96, because as I said, supporting variable prefix lengths would unnecessarily inflate the array option. And I'm not really aware of any implementations doing non/96 prefixes. So the question is actually, do we really need it? And if we need it for some special use case, maybe it's actually worth specifying another array option for variable prefix lengths, which will be bigger, but you don't have to use it if you just need /96. And I think it's been productive discussion on the list. There are few clarifying things we still need to do, because we got a feedback that some sentences might be not so clear. So if there are any comments, question, and we'd like probably to ask for adoption if working group thinks it's a good idea.
So, hi there, Fred Baker, ISC or something like that. Number one, I support adoption. I think this is much better than what we're doing right now. Number two, I've got an issue, and that is that you don't want to translate private addresses into an IPv6 prefix. Yeah, so third sub-bullet there. That creates a problem. So last week, I spent some time in a country that is trying to deploy an NREN. They want to connect all of their primary and secondary schools, and they want to run an IPv6 only network. They believe that they're going to have some IPv4 requirements, and they need to be able then to connect to some upstream network. And so what they would like to do is run 464 XLAT, which would take the IPv4 traffic, put it into a v6 prefix, send it across the network, and then run that through an AT64 translator. So it now comes up with a well-known IP, or with a global IPv4 address, and it goes to whatever, and it does whatever it needs to do. If I tell them they cannot use a private address in the school, which would then get translated into whatever prefix is being used in context, then they have to get a global IPv4 address for each school. Your third sub-bullet cost them $25 million.
No. It's well-known prefix. It's only if you're using 64FF9B, the RFC for translator says must not. This is what we're referring to. It's not us. It's a translation RFC clearly states that private address space must not be translated using well-known prefix, which 64FF9B. If you're using any other prefix, you are perfectly fine. And again, it's not our draft limitation. It must not from translation RFC.
Translation RFC that I wrote.
It's for NAT6 for IPv4 to v6 translation. Can't remember the number. It's RFC which specifies the algorithm from translating.
6145?
Yeah.
6050, I think.
Yeah.
6052,
yeah.
are you talking about?
Maybe.
Yeah. I'll find you a reference during the break.
Okay. Well, then that needs to be an errata. I think we need to be able to put a private address into a translated prefix. Okay.
Yeah, so we can fix it, but I think we're basically referring to the existing standard. And again, if you're using non-well-known prefix, any other public prefix, you can translate. There is no limitations here.
So you have Jody, Mark Andrews, and then remotely,
Okay.
and then Ching. Jody, go for it.
Okay, Fred, anyway, in this project, we know the project. I don't think that's a problem. We can talk later on that, okay? I support the document. I provided some comments in the list, and I realized it with your presentation that I missed something, but more or less I think we are aligned. The preference order that you are suggesting for the selection of the prefix, I think you said first the PCP.
PCP because
Yeah.
then this as an array option and then 7050.
Okay. In our document in B6 Ops about the CEs, which IPv4 as a service support, we had the same order. I included in one of the versions the support for this document, but because we were in the last call, I need to retire that. But I have included also one more document. Maybe you want to check that. In the actual version 10 of my document is 464X lat. Let me find it. -5. So I am doing this order: RFC 7225, then 8115. Before that, we'll go this one, I think.
So Jody, I think you could take this on the list.
Yeah,
probably.
we can check on the list, but I support the document, and I think we should adopt it.
Cool. Mark, you have been pressed.
Yeah. The assumption here is that this is an IPv6 only network. We're going to have lots of networks. We have DNS6.4 from the ISP over the over the access network and dual stack internally. We really do need to cover that sort of scenario, and that actually means we need to know which local addresses, they may not be RFC 1918 addresses, are excluded from processing. We can do that relatively easily by pointing at a DNS entry, which will actually give you an ACL.
So with DNS,
make your option bigger.
So with DNS, you're basically going back to 7050, right? So you kind of have to trust the DNS, and so I think it's a bit tricky. I do not see how we can do it with.
I can have that entire ACL DNSX signed. There's nothing that I can't trust out of that.
So as the slide says, I actually suspect that in most cases for endorsed tech enterprises, you could just use well-known prefix and they will be using private address space, in which case you just wouldn't be translating it at all.
Therefore, we're dictating how the network operator numbers their address space.
Yeah, kind of. But again, basically, it's not any worse than existing mechanism. You cannot do it now with any mechanism.
The option is not flexible enough for real life scenarios.
Can I take that? Yeah. I'm sorry, that's not true. This is Lorenzo Clady. All of the implementations have no support for this. None of the other mechanisms that are implemented have any support for this. Okay, so no host is able to do what you suggest today. So I would push back on that statement.
You're using, all your hosts are capable of doing this with proper routing information. The fact that we've got very limited stuff there does not mean we shouldn't make it actually work.
So, Mark, would you be able to propose text or changes to this document, or are you fundamentally?
I suggested earlier that we add a DNS name that points to a record, an APL record. The option that is already on the list.
Okay, I think we could just take it on the list probably because I see two other people on the line. So I don't know how we're doing this time.
Yeah, so that's a different approach that we have to consider, I think,
Yeah.
and we have to take that on the list. So close the microphone line and Singh, please, go briefly.
Cindy from CERNET, I support this document, but I want you include none/96 into this draft because we have user cases.
So the question, shall we consider just having two options, one flexible variable length and one this one, so you can actually minimize the size of array for most other networks which basically do not need non/96?
Yeah, just the requirements, so the working group can decide what's the format. Thank you.
So Krishnan, so I did read the draft. So there's like something funny about the type. It says like RDNS is option type. You're not planning to reuse it, are you? On the draft, it says like the type is the RDNS is option type in the draft. So I can probably send something.
Maybe just copy and paste typo. Yeah, just point it to me. We'll fix it.
Okay.
Yeah.
And the second thing is like it points back to 7050 section 3, which says do a quad A query for IPv4 only .arpa, right?
Yeah.
So I think it requires like a more specific pointer to what to do in 7050. That's specifically about like merging the multiple prefixes you learned, right? The pointer is like too vague.
Oh, okay.
Okay. And the other thing is like it's not clear is the lifetime, right? Like so the other like 70 to 25 doesn't have a lifetime in it at all, right? And the lifetime is like, how is it aged, like, how it gets like thrown out and everything is not specified. So I'm not really sure what the lifetime adds, and that could give you the extra bytes if you want.
Lifetime adds an ability to deprecate the prefix and change from one prefix to another, because if I need to change the prefix, I can currently, the same as we're doing with PIO, I'm sending in one array two options, one for old prefix with 0 lifetime, one new prefix with non-zero lifetime, and hosts are instructed to stop using old prefix and start using new one, because otherwise you have no way whatsoever, right, to change the prefix for the host. You cannot signal it back to host.
But then you need 2 lifetimes, right?
No, you just need one. As long as it's non-zero, you're using it. If it's 0, you stop using the prefix. Done.
Okay.
You don't need this valid and preferred like with PIO, because we don't need it here unless I'm missing
So
something.
what happens?
We're really running out of time
Okay.
now.
I think we can take this on the list, but I think we need better specification of the lifetime, because it's not clear to me like what it adds.
We certainly failed on lifetimes before with the DNS option, so that would be useful. Lorenzo, very quickly, please.
Yeah, I have no objection to adding this stuff that I'm not going to implement anyway. I'm fine with that. I really am. I do want the working group. I'll leave that up to the working group. I mean, but my implementation is going to do what I want it to do. But I leave that up to the working group in the sense that we should think about, like, this thing is going to be with us for a long time. Do we really want to put all the stuff that nobody uses today in it? And that's really a question that the working group needs to decide. Variable length. I mean, Eric has a hack. If you let him talk tonight, I'll say it. But yeah, and for the DNS record, right? Like that doesn't exist at all today.
We could have it as a different array option actually.
So I had closed the line, but since it's you, Eric.
Oh, I love you too, Willie. Jen, I'll talk to you and Lorenzo later. We can get some text, but I think if the option is 8 bytes long, then it's /96, and if it's not 8 bytes, then there's a length field in there somewhere.
Yeah,
and that way, the common case can be short, and the longer and non/96s will just be a little bit more space, but that's the price you pay. So that'll be fine.
Okay, so but what do you want to do? I was about to say to Jen that can you go and talk to Mark Andrews, really understand his point, and come back to the mailing or the working group on the mailing list and summarize that. At least I would like us to understand his point better, and then we can do an adoption call just on the mailing list. I think there is support for this draft, so I think that's going to be just a quick thing. Yeah. Right. Okay, Tom Herbert, you are remote, I hope.
Okay. Can you hear me? Can you hear me?
We can hear you very poorly.
How about now?
It sounds like the gain on the microphone is too high, perhaps. Just continue speaking and see if the Michiko people.
Okay.
No, yeah, it's yeah, you're clipping, so it's.
It was good on the test.
Yeah, if you speak, you just whisper, we might be fine.
I just whisper like this.
Yeah, and put your
Is that
microphone
better?
better away from your. From
Tom, put your mic out so it's not in front of your mouth directly. Yeah.
Okay, how about now?
That's perfect. Leave it there.
Okay, thank you. Okay, so I'm going to talk about IPv6 options, specifically destination options, hop-by-hop options, and some of the efforts to make them practical for use on the internet. There are two drafts that are part of this. One is ICMP limits. That's actually a working group draft. It's incorrectly labeled. That draft has been around, I believe, since May, and got some initial comments, and I think would like a response or feedback on whether that should be working group last call. The other draft is newer, update ops. So this is basically clarifications of options from RC 8200. And my question there would be, should this be a working group item? Next slide, please. So general problem, as probably everybody knows, IPv6 options are not considered viable. And there's been a lot of discussion on this, a lot of workarounds. Clarifications have been happening. So there was obviously the clarification in RFC 8200 about hop-by-hop options. Some of the other issues people have quoted. So there's no useful options defined. Processing overheads, TLVs are very expensive. Of course, there's extension header drops that are described in RFC 7872. And in addition, the options really are unlimited to some extent. So there can be a lot of these in a single packet, and that creates a DOS vector that's pretty obvious. And RFC 2460 required clarification on the hop-by-hop options. Next slide, please. So in terms of useful options, there's at least 4 that I know of that are being proposed. So there's a truncate option, MTU option, and in situ OAM. But all of these, I believe, are hop-by-hop options or destination options in the case of truncate. Firewall and service tickets is a proposal to use hop-by-hop options. Next slide. So RFC 8200 created this exclusion for hop-by-hop options that allows nodes to basically ignore hop-by-hop options. This was a good step forward in the sense that it relaxed a requirement that every node has to process these, which would have meant every router has to have hop-by-hop options basically in the fast path. So that was fairly little austere as an option, and this was relaxed in RFC 8200. However, this did raise a question for me, thinking about specifically the truncate option. In the truncate option, that requires that the packet is dropped if the packet has been truncated, which means somebody along the path has to actually look at that option and drop it. So when I made the recommendation that that should be hop-by-hop option, it occurred to me that if everybody ignores hop-by-hop options, including the final node, then the packet could actually be delivered to the destination that's corrupted. So if you look at this specific text, it's now expected that nodes along a hop-by-hop or along a packet's delivery path only examine and process it. I think the question that I'd like to raise is, does that mean that the destination is allowed to ignore the hop-by-hop option, or is that not in the packet's delivery path and has to actually process it? So that's probably a question that I would raise to the working group or on the list. Next slide, please. So the update options clarified adding, removing, and changing options. Basically, this says that The only thing that can change in an option is the data. If the third bit in the option type is marked, the option is changeable. So option types cannot be changed, option length cannot be changed, options can't be deleted, can't be added, and that includes extension headers, hop-by-hop options, destination options cannot be added or deleted. So I believe this is just a clarification of RFC 8200, and that was the spirit of our RFC 8200. Next slide, please. So another clarification and update options is changeable destination options. So in fact, the bit in the destination options type can be marked as changeable, and RFC 8200 was not exactly clear on that. So the text in the update options is in two modes. So if the destination options precedes the routing header, then any visiting node may change the option data. So this effectively are nodes en route that are being visited. So that is along the lines of what changeable means. Now the question is, how does a node know that the destination options are before routing header so that it can ignore it? And I think the heuristic there is that the node can actually look at the next header of the destination options. If the routing header is present, the next header should be, according to the canonical ordering, the routing header. The other option is if the destination options are after or without the routing header, then the option cannot change en route. However, the bit can still be set, which means the authentication, for purposes of authentication, the data has to be zeroed. So it's unchangeable, but still has to be consistent with the authentication header treating it as changeable. Next slide, please. Another update to the update options is destination option processing requirements. So again, this splits it into options that precede the routing header and those after the routing header. In the case that options precede the routing header, the proposal is that they may be examined or processed by intermediate destinations. And the rationale for this is that when a routing header is in use, the likely nodes that are intermediate are probably more like routers or middle boxes than end host. So in the same rationale that hop-by-hop options can be ignored by those sort of devices, this is proposing that destination options that precede the routing header can also be ignored in the same way. Destination options that are after routing header or there's no routing header, they have to be processed regardless. There's no exclusions to that as far as I know. Next slide, please. So this is the extension headers limits, the other draft, or no, I'm sorry, this is RFC 6434 BIS. This was text that we added in order to provide limits, and this primarily solves the problem that options can be unlimited. So it's very easy to create a large packet with a whole bunch of options that are basically known to be unknown, however marked not to be skipped. So this is an easier denial of service attack. I think I had packed packets with like 700 or 800 non-padding options, and there was a big performance hit when a node tried to process all of those. They have to be sequentially processed, and per the current specification, they have to be processed. So the idea was to limit the padding options, disallow unknown options optionally, but also have limits on the number of non-padding options and limit the length of both the hop-by-hop or destination options extension header. So this text was added to RFC 6430 for BIS, and actually it has been implemented in Linux and has been running for a while. And the default limits for number of options is actually set to 8. Next slide, please. This is the ICMP limits. So this defines a number of ICMP errors to deal with extension header and option limits. 4 of them are defined in parameter problem. The first one actually is an exception to allow intermediate nodes to send the unrecognized header error. This was because some intermediate nodes will drop these packets, and obviously it would be better if they gave an indication why, as opposed to being silent on that. The other three kind of conform to the limits that we defined in the previous slide. So extension header too big, exceeded that processing limit, header chain too long, or too many options in the option header. These, when they're reported, the pointer points to the offending byte, which should be used to determine what the maximum length was, so that the host can actually either adjust what it's sending to fit into the length or the maximum, or at least report it and log it. The other one is actually destination unreachable. This one is not specific to the IP header. It's actually a more generic thing that we added. So the concept here is that the header chain, whether it be IP or encapsulation headers, what have you, is considered too long. The rationale here is that there are intermediate devices that have a parsing buffer, and if that parsing buffer is exceeded, they may drop the packet, so they could actually send this ICMP error in that case. As I said, the behavior of receiving an ICMP error on the host, they can either adjust what they're sending or they can log it. However, in any case, there is some error that's being returned and now with the ICMP errors for these. Next slide, please. I have one point about the implementation. So we know that there's a lot of legacy nodes that don't handle options very well. So we expect RFC 8200's exclusion to help the devices skip options instead of just dropping them for hop-by-hop options. But that is a difficult problem that we need to solve over time. We do expect the limits that are being allowed in RFC 6434 BIS should aid both hardware and software implementation. As I said, the skipping hop-by-hop options should be straightforward for a device to implement. And the one trend that may be very helpful here is the emergence of programmable devices. These should make it a lot more amenable to implement support for options in intermediate devices. One comment about that is both P4 and BPF, which are kind of the languages or the bytecode of these programmable devices, typically don't allow loops. However, through unrolling, it seems reasonable that they could allow about 8 options. So 8 options in a packet, they should be able to process those fairly efficiently. Next slide. So that is all I had. Any comments?
Ron, please go ahead briefly, please.
Ron Bonica, Juniper Networks. I think this draft may be premature. And I'll take an example to show how. RFC 8200 may be a little bit loose about its specification of processing destination option rules. You bring up one rule, whether it's okay to ignore a destination option that precedes a routing extension header. Well, maybe the rule as it's stated in 8200 is correct. Maybe the rule as you stated is correct. We really don't know because nobody's ever specified a destination option that comes before a routing extension header. Lacking the operational experience, lacking the protocol design experience with this destination option, do we want to make the rule now, or do we want to wait until we actually want to use this option and then think about what the rule might be?
So this rule was actually motivated by segment routing, which has TLVs. And one of the rationales they had for TLVs and segment routing, as opposed to using destination options before the routing header, was that destination options could not be ignored, and they wanted the ability to ignore them. So that was actually the rationale for this, was to satisfy one of the requirements that at least the segment routing TLVs had. And I was one of the believers that destination options should be sufficient for what they were doing with the segment routing TLVs. So that's kind of the background of where that rule came about.
Is it possible that in the future somebody might actually want to use a destination option before maybe a different routing extension header?
Sure.
Why slam the door because segment routing needs it one way?
Well, and so again, the principle here was that the devices that are in a routing header, our intermediate devices, which typically wouldn't process those. What I'm afraid would happen is we would define destination options before the routing header, and we're going to get into the same state we had in hop-by-hop options, where nodes are just ignoring them without any specification. So I think this is, maybe it is premature, but it's an adaptation to something that's likely to happen, at least I believe.
A better approach might be to say, if a packet has a routing extension header, has a SRH, it may not have destination options in front of it. So that way you make a rule that's SRH specific, as opposed to making a rule that impacts future work.
Right, but as I said, then, so the argument here is that the TLVs in the segment routing header were unnecessary because they're redundant to the purpose of the destination options.
Everything will be a quick one regarding the ICMP message for limits. I like it. The only thing is that it expired in July. Do you intend to make a new ref?
Yes, I can update it. Feel free to comment on it if you wish.
Okay, so we're going to wrap this up. We're over time. So I think this needs more discussion on the list, but I also note that there are two drafts here. One is just defining ICMP error codes, which I think is a much lower bar than the other draft, which is changing behaviors. So they need to be considered separately. Okay, thank you, Tom.
Thank you.
Okay, so I guess I'm up. So a few months ago, Ron proposed a change to PathMTU discovery using packet truncation. That kind of opened the door a little bit to look at PathMTU discovery at the internet layer with new eyes. The result of that, I wrote a short draft trying to summarize the set of, the solution space for PathMTU discovery. So I'll quickly walk through that, since I was the reason didn't manage to time very well for all the other speakers, so we're now a bit short on time. I'll just solve that by speaking very quickly. So why are we doing this? RFC 1981-8201 has some issues with robustness, especially around signaling back to the sender. It's throttled in routers. That's RFC 4443. It's filtered in firewalls. It's ignored by host. Doesn't work well with Anycast load balancing. With v4, it wasn't even enough payload in the ICMP error message to correlate which sending packets we were talking about. It also requires multiple round trips to detect the full PathMTU, and it detects MTU per destination, not per flow. So that's why can we do anything else? There's been a lot of work on PathMTU over the years. We haven't made much more progress than where we are now with ICMP-based PMTU. In the routing area, there's work going on now, especially around segment routing, where you advertise the MTU in the routing protocol. So that's one option. Multicast, they're doing their own thing for beer. Haven't looked at those in detail. What we want to have is, of course, robust. That should be possible. Deployable is probably the hardest one. It would be nice if we could detect the PathMTU in a single RTT. Not making an easy target for filtering, which means that the sender of the signal back should be the destination host. And it should probably be hidden in the transport or application stream, not as a separate ICMP message. It would be nice if it was per flow, because packets with different 5 tuples are routed differently. And there's a separate topic on supporting per neighbor PathMTU, which is, you have multiple hosts on the same link that would then use heterogeneous MTU on that link to communicate. When you talk about the solutions, think of this as a separation, that we separate how to detect the MTU and how we signal back to the sender what the MTU actually was. And the signaling can be done, either with the existing ICMP package to big message, or it can be done with a separate L3 extension header. It could be done as a TCP option or in the application. Okay, so let me quickly run through the possible solutions that I found. I'm sure I missed some. Just punt the problem and say we can't solve it on the network layer, punt it to transport and say they have to do something like 4821 or the similar one for UDP. There are some downsides of that. It's not super efficient. They can't distinguish between, congestion drop or an MTU failure, for example. So it's not perfect, but that's pretty much what transport has to do today anyway. Because what we do at the network layer isn't robust, and it probably isn't going to be, right? At least for not.
It's going to always have to do that.
Right. Solution 2, do nothing. That's kind of the default option, and we're all lazy. Solution 3, well, we could do in-path fragmentation. Solution 4, we can just fix the MTU at 1280 and done with it. Then we have solution 5, which is truncation, where the sender sends a packet sized to the outgoing interface and sets a truncation eligible flag in the packet. The intermediate routers then, if they hit a smaller link, they will truncate the packet and say, set a truncated flag. But there are some issues with this. If you want to do special probe packets, you can do that, or you can embed it with the normal data packets. Then you have to record your original payload length. You might hit issues with firewalls and things that check TCP checksums, for example. So you have to do a little bit of magic and then carry some metadata with the packet when you do that. Ron has a session on this afterwards with more details. And then you have solution 6, which is you can just record the MTU along the path. Bob has a session on that, which is essentially you send a small packet, for example, TCP SYN with a new hop-by-hop header option in it, routers on the path, record the MTU as it gets smaller, and then the receiver signals the MTU back to the sender with one of the before mentioned options. And then you can either use a separate probe or you can put this in normal data packets like a TCP SYN. And the conclusion is blank. We don't know. This is really a clean slate, throw all the balls up in the air again, see if we can come up with something better at the internet layer. I mean, we clearly can do this in the transport layer or in the applications with probing. But it might be helpful if we could give some better hints and clues to the transport layer. So, yes, questions, Michael?
Michael Abramson. So if I say all of the above and probably add 3 or more or something on the way, I mean, there is no single solution here.
I'm not doing that one.
No, but it's like, first of all, I think you missed a few reasons why this doesn't work. I keep iterating it. People seem to keep forgetting it. It's like, layer 2 devices in the middle is not configured for lower MTUs. You get silent drop. There are lots of reasons why this doesn't work. So we're going to need everybody to do a little bit of everything. So the packet, we need to tell transport that they need to do packet layer, path M2 discovery for robustness. They can't just say, network will fix it and we don't have to do anything. So they're going to do that. Some of the other ideas are, I think they are good, like the truncation on the way might, I don't know, what do the hardware people say about the truncation part? Like people making NPUs, are they happy with that or?
Well, it's not hard to truncate a packet.
This is why we're talking about it here today.
Yes.
Right,
yeah,
but
yeah.
are there, okay, are vendors talking to the hardware people? Not the hop-by-hop one.
Well,
okay, so you're punting it. Okay.
Yeah.
Okay.
But yeah,
okay, so it's in this slow path. Okay, so it's punted. So you're not always going to do that, right? Because if there's a lot of packets, you're not going to be able to handle them.
Right.
So if that's going to work, I would say it needs to be done in a high, not slow path.
Yeah.
But okay.
So we had 2 more sessions, right? One on truncation, one on record.
Right. So okay. So in summary, yes, we should definitely work on this. I fully support this. I have this problem, and I want to help fix it. And yeah, we need to figure out what we want to do. And I think it's not going to be one of these solutions; it's going to be all of them.
Okay, super. So Gori and Bob, you're up.
Oh, boy. We're good friends.
I do this bit, yeah.
Okay, why don't I do the start? So, or go to the next slide. Yeah, so we know the PathMTU discovery isn't working well. So the idea that this came from actually talking to Ron with his truncation proposal, with the notion that one thing that might be better than what we do now of having the routers on the path send back packet to big messages, which don't get there for a whole bunch of reasons. And there's also a problem with the trust relationship because the source host doesn't know who these intermediate routers are ahead of time. Was that, maybe sending it from the destination host is a more reliable way of getting the feedback. And so Ron proposed the truncation draft, and I was thinking, well, I wonder if a hop-by-hop option would do this to sort of, you could use to record the minimum MTU to the destination, and then if it gets smaller, then the destination host could send that information back to the source. So next. We can alternate.
We alternate. Okay, that's cool. So, it makes it difficult. I have to read the slide. Adapting to varying path MTU needs to be done over the connection lifetime. We can't just assume that we find it out at the beginning and that's the way it stays. For short flows, it's probably true. For long flows, it's certainly not true. And that might mean raising the MTU from time to time. We can do all this stuff at the transport, of course, because I've got a draft in TSVWG, which we'll talk about this week, that does it at the transport. But it can require an awful lot of probes if you want to go for big path MTUs. And we'd like to do it in a single round trip if we can, or at least have options for doing it really quickly. And it needs to work with devices that read transport headers, because these guys will need real packets, because the route the packet takes through the network will depend upon the transport headers, such as the UDP port information. So that's the goals.
Okay, so I think you understand the problem of, sender knows the MTU of its outgoing link, but it doesn't know anything about the rest. So next. Oh, okay, so this is the format of the hop by hop option. I mean, it's very simple. It just has the the option type and all the bits, and we know that 8200 now says it's okay to skip these things, but I was thinking this actually might be a useful hop by hop option, and the idea here is that if the if at every hop it sees that the MTU has changed from what was originally written, that you write the smaller value in. So if the outgoing is less than, you update the thing, and then the destination receives this, and it can send a packet to big message back to the source, so it will know. Yeah, we're trying to do this quickly because we're out of overtime.
But it might be wrong, and we know this. That's okay. We just want a hint. We're going to drive this at the packetization layer to do the real checks. We just want a good hint as to what size to probe for. And we don't rely on this option. Read the draft about that, but really, if routers don't update this on the way, then okay, then we just don't get the information and we have to try probing in the usual way. Do you want to do this now?
Yeah.
Okay. 3 scenarios, very quickly. This scenario is where everyone implements the new option, and lo and behold, you quickly find out what the MTUs are, all the places on the path, even including your tunnels, which reduce it just by a tad. You find it very quickly by getting the information by one RTT, you probe for it, you can use it. If everyone implements it, but they don't implement big MTUs, then you find the small MTU. That sounds good, yeah? Somebody chooses not to implement it, or somebody ignores it, or you have your ugly layer 2 device that was misconfigured by accident that has a lower one, then the answer you get back is too big because it's the answer you submitted at the beginning and it wasn't changed. You get it back. Well, okay, it's not too bad. You found out what the remote endpoint might use. That might help. And you just probe.
Yeah, and so there's as Oli talked about, there's other work reporting high drop rates in this stuff. There's other drafts. It's also going to be discussed in the transport area, or TSVWG, I think tomorrow? Tomorrow. Okay, is there more? Yeah, and so sort of the adoption question, but sort of what do you think about this?
Michael Abrams. So I think last time when I looked at this, it didn't specify which MTU. So if I have interface MTU, IPv4 MTU, and IPv6 MTU, these are three different values. Yeah. Is it the whatever packet type came in MTU that you want back?
You're forwarding this packet. You make the forwarding decision. You take the MTU you're going to use for forwarding.
Okay, so the max encapsulated packet I can do at egress. Okay, and then I made a point, I think, about ingress. You have two interfaces. Packets comes in somewhere and it goes out. And if my ingress interface MTU, which one? I should choose the smallest of these two, right?
You send it to the forwarding plane. You look to see how big you can send. If you can't send it, then you reduce that number. So you're looking with the protocol type you were using.
Yeah, on the but if my MRU on where I receive the interface, if the MRU is smaller than my MTU, do I report the smaller one here? Otherwise, it's meaningless.
Well, so this only applies. You only do this for the outgoing interface MTU, and you don't send this in big packets because
no, I know, but it's like I'm getting it from an interface where my MRU is 1500 and my egress is 8000. It's this 8000 packet is meaningless because my MRU, I'm going to drop anything I receive from that interface that is 1500.
So you only update the number if it's smaller than what the previous hop was.
Okay. If you've got a receive limit, you could also update it. Yeah. Okay.
I think there should be text on this.
Yeah. Okay. I now get it, and I see what you're saying.
So discussion. So one of the things I didn't understand very well is the feedback mechanism. So one of the options was like an ICMP packet too big to send the stuff back.
That would be my preference because I can then check that is actually associated with the flow I'm probing on.
So what happens to the socket itself? Because like one of the proposals was sending it along with the SYN packet. So would that reset the connection after? Like what happens to the socket? It should signal an error because it's a hard error. The packet too big. It's not on the soft error category, right?
Does packet too big imply that the destination also drops it when it's issued by the destination? We don't usually have ICMP like this from the destination.
Right.
So
I think it's going to reset the connection. That's what I think.
Wait. We were hoping it wouldn't be dropped. We were hoping that somehow the packet too big from the destination wasn't treated in that way.
Okay.
We need to talk about that.
We'll talk about that. Yeah, thanks.
Jelinkova, about new data, I'm going to get you some because I'm running Atlas measurements on hop by hop and destination option right now to see what's the packet rate comparing to what I did a couple of years ago. And I have a question. I didn't find it in the draft. Are we sure that routers do not do load balancing differently for packets with extension header and without them? So you might actually go through completely different path. I'm sorry, I'm asking something obvious.
No. It's a good question.
We need to measure that one.
We need to ask vendors how they do that because you cannot absence of evidence is not evidence of absence, right? You cannot measure.
Vendors, how do you do that? Talk to us afterwards, please. That's okay. I mean, like it might work if we configure it. And if it doesn't work, then you probe some other way, right? I mean, the question here is, can we get better information? It's a futuristic thing, but maybe if you own all your routers, you can actually do this in your data center right now, and stuff will start working.
Okay, and now I'm channeling Peter van Dijk is saying, for the specific case of DNS, where a resolver sends a query to an authoritative something, the auth sends a response. The resolver might issue the PTB and then throw the packet away. However, if it is the resolver that wants to know this number because it can communicate it as an eDNS buff size. So for both this proposal and the next one, it would be wonderful if we could expose this number on the receiving end to the application layer. So basically, I think he wants to know on the reception side, the receiver should get this information as well.
Right. Yeah, it would be silly to hide it. Okay, should we go to the next one?
Yeah, I think let's get Ron up here and talk about truncation. Thanks a lot, Corey and Bob.
Okay, exercise and talking fast. We will skip this slide because everybody already knows this. What network services are we trying to get? The truncation draft is trying to provide a mechanism so that when a source node sends a packet that is bigger than the PMTU, he gets immediate feedback. The feedback mechanism has to be activated on a per session basis by the upper layer protocol. By default, the feedback mechanism is turned off. So the upper layer protocol turns it on for a session that he wants feedback on. The feedback mechanism must detect PMTU decreases, but it's not required to detect PMTU increases. And it must be more reliable than PMTUD is today. But it's not required to be 100% reliable. And the reason for that is that's a goal that we just can't achieve. So what's the approach? We want to make PMTUD more reliable. Today, when a source node sends a packet bigger than the PMTU, it gets one ICMP message, and that ICMP message is sent by the intermediate node that did the truncating. In the proposed approach, the source node will get two ICMP messages, one from the intermediate node that did the truncating, and another from the destination node. Now, to make that happen, obviously, the packet needs to get to the destination node somehow. If the network fails to deliver the ICMP message from the intermediate node, there's some chance that it might deliver the ICMP message from the destination. This is more likely because it's more likely that the destination node will have a viable path to the source. So far, so good? Okay. So let's talk about the current version of draft LEDI, the version that you read if you look at what's posted. The source node marks a packet with a truncation eligible option. If an intermediate node can't forward the packet because of an MTU issue, it sends an ICMP PTB. It overwrites the truncation eligible with a truncated packet option. It truncates the packet, recalculates the upper layer checksum if possible, forwards the packet to the destination. If the destination recognizes the truncated packet option, it sends an ICMP message and to the source, and it discards the packet. If it doesn't recognize the truncated packet option, it sends an ICMP parameter problem and discards the packet. The reason for that, the truncated packet option begins with the bits 1, 0. If you don't understand an option that starts with 1, 0, that's the required behavior. Now, this drew some pretty sharp criticism. There were two things that people didn't like. One is updating the checksum in flight. The other is overriding the destination option type in flight. So Sunday, a bunch of the folks who raised the objections, we all went into a smoke-filled room. Yes, we were smoking tobacco. And we came up with two things that we might do to fix the problem. One is just don't update that checksum. Leave it broken. Now, this reduces the risk of the truncated packet being introduced to the data stream at the destination. Now, how big is that risk? Well, it's hard to tell. The packet already carries an option that will cause it to be discarded. So it reduces the risk, maybe if there's some bug and the destination doesn't, deal with options that start with 1 correctly. What's the cost? Well, it reduces the reliability of the feedback mechanism. The reason why is it reduces the probability that the truncated packet will actually make it to the destination. What we discovered is an awful lot of stateful middle boxes verify checksums, and if the checksum is wrong, they discard the packet silently, so it's just not going to make it to the destination. So, yes, this does answer the criticism, but it critically reduces the reliability of the mechanism, and it critically reduces the applicability. We'll talk about that in the last slide. The next thing that we could do is collapse the two options. You saw two options, truncation eligible and truncated packet. Collapse them into one. It's called truncated. The ACT bits are 1, 0. That means if this arrives at the destination and the destination doesn't understand it, it's going to drop the packet and send a parameter problem message. The change bit is 0, which means it can't be changed in flight. And the option data is 2 bytes. The 2 bytes are exactly the same value that the packet had at the source in its IP payload length. So how do we process this thing? The source node marks the truncation, marks the packet with the truncation destination option, the option we just described. If an intermediate node can't forward it, it sends an ICMP message, it truncates the packet, and when it truncates the packet, it changes the length in the IPv6 header, and it forwards it to the destination. If the destination doesn't recognize it, it drops the packet and sends an ICMP parameter problem message. If it does recognize the truncation option, and the length in the option is different from the length of the packet, it knows that the packet has been truncated. So it sends an ICMP PTB and discards the packet. And if it recognizes the truncation option and the 2 lengths are the same, that means the packet hasn't been truncated. In that case, you can process the packet. Now, let's talk about cost and benefit. The benefit of collapsing the two packet types into one, the 2 option types into one, is it avoids overwriting the option type in flight. This really is a benefit. When we were changing option types, this mechanism didn't work with the authentication header because it made the authentication header integrity check break. Now it works with the authentication header. The cost is additional cost incurred when the destination node doesn't recognize the option. So let's say you're sending to a destination node that doesn't recognize the option. In the old formulation, if the packet wasn't truncated, the truncation eligible ended in 00, no problem. There's no, you accept the packet. In this case, if the destination doesn't understand the option, you're going to drop the packet, get the parameter problem, and you waste an RTT discovering that.
Minus 2 minutes, Ron.
What?
Minus 2 minutes.
Oh, okay. Let's see. That slide we can skip over. Next steps. I guess we're not going to discuss the proposed changes here. Best thing we can do is update the draft and, okay, can we take one comment?
Take one comment.
Okay. Igor, what's your name, Igor?
My name is Igor. Igor Lubashev Akamai. I was looking at the checksum issue. I'm not very sure. I mean, we have a performance enhancing practice, do checksum recalculation all the time for TCP packets. And basically that's TCP UDP is the only thing we could actually even recompute a checksum for. And there is a list of things that will break if checksum is wrong. I would just want to add to that the destination is most likely just going to discard the packets. Even if it gets through the firewalls and middle boxes, it will discard it either in hardware receive checksum offload or very early in the kernel stack processing. Yeah, so the checksum seems to be very useful. And again, it is recalculated all the time by middle boxes now. And I tend to agree with that. Best thing we can do is bring it to the list.
Well, so I was going to make an announcement. So I reserved, if you're aware, there's not working group sessions on Friday, but there are side meeting working things. So I reserved a room on Friday from 10 to 12 with the goal of talking about, discussions from 6man and TSVWG about PathMTU. So I'll send mail out.
I'll be in the air.
Oh, well, they have internet on the plane. Sorry, but the goal, I think it would be useful to continue this discussion and hopefully enough people can attend and make it useful. And then we'll continue on the list. But I think that'd be a good use of the side meeting. And so you won't get to go be a tourist in Bangkok, but we can talk about PathMTU discovery, which is a great topic.
Okay, and Eric Bank asked me to announce another side meeting that happens tomorrow on the provisioning domains. That's from 10 to 11. He'll send an announcement out on the mailing list for that. Please, if you're interested in PVDs, have a look at that. Could the blue sheets be sent forward, please? And I'm terribly sorry to the two authors for the lightning talk sessions. We have to cancel those. We're out of time. They will be in the proceedings, and we can continue discussing those on the mailing list. And I guess we'll see you in Prague. And it sounds perhaps like we should ask for a 2.5 hour session instead of 2.
Oh, if you must.
Yes. Which one?
No.